Hi, Gunter. Welcome to the Future Proof Operations podcast.
Hello, Benjamin.
Great to have you on the show, Gunter. Could you give me a short overview of who you are and what you are doing?
Yeah, thank you first to having me invited to your podcast. So, my name is Gunter Beitinger. I'm responsible for manufacturing at the business unit factory automation at Siemens AG, also responsible for digitalization of our factory. And since almost 1.5 years, I'm also heading a small startup inside of Siemens, which is developing a solution for tracking and tracing of the carbon footprint along the supply chain.
Sounds like you have a lot of responsibilities in different kind of fields. Help us to understand what you're doing in the way that you take us through usual business day. So how does that day usually looks like?
What is the best way to describe my day, which is of course disrupted also, or let's say a day with a lot of different topics. But I think the best way is to describe it. So my first responsibility is manufacturing. So I'm always thinking, what do I need to do, or what do we as a team need to do to keep our factories up and running and to prepare them for the future and the challenges which are ahead of us. So, and these are the the things which would keep me up at night, because there is always the thought: could we do something better? Do we have something overseen? And that is the guiding principle for my days. So first, when you have, there is no typical day, but in the topics, but maybe in the structure. So in the morning, typically you get informed what happened in a short aspect, and some stand-up calls, what we call, with several teams. So to see where they are, where they are going, what are they on their agenda, and then strategic meetings to see where the status quo, and then maybe we can call it forward-thinking meetings. What do we need to do? To prepare ourselves. Our guiding principle is the Hoshinkanri. I don't know if you know this, which is a methodology which allows to align all the different departments um, on key initiatives, so that, with other words, are that we are pulling all in the same directions as a team. So that's maybe something which is important.
Mhm. Yeah, pulling teams together, transforming companies, adapting companies. I've learned in our preparation call already that you have a lot of experience in that kind of field and that you really care about that. Today, we want to focus on the adaptiveness of manufacturing companies, especially in terms of crisis. Like nowadays, we have a lot of crises, or we had them with the pandemics, trade wars, we have supply chain problems. And I would like to understand how manufacturing companies should adapt and respond in a world of different kind of crisis.
Mhm.
What do you think on a high level about it?
Benjamin, I think you're hitting a very important topic, and as I said, now I'm manufacturing. I'm almost now 20 years in manufacturing, and one of that things which we keep me up is that exactly what you're describing. What do we need to do that our factories are up and running and will work tomorrow, and how do we prepare and shape them as a single factory, but also as a network? I mean, uh,
Mhm.
as you know, so that the network can also support each single factory. So we are living in a VUCA world. So we have a lot of challenges, and these challenges are already becoming manifold, as you already stated them. When we look back, we have seen the trade wars, around, and we have disrupted supply chains, which which give us problems in the supply of the material to our factories, and the pandemic situation also impacted locally our factories, as workers were not able maybe to go to the factories, or even to go out of the factories, and they had to stay inside the factories to continue the work. And digitalization has just begun, but the journey is not yet finished. Then we have the war on talents and the challenges with becoming the right people on site, and sustainability. And the impact on sustainability on our operations are increasing and increasing. And I think in my network, at least, we had the first time that we even were not able to produce for a few hours in our factory due to shortage of energy, because the energy were delivered by hydrogen, and there was the water level so low in this area. So this becomes very even very close now, this topic of sustainability, carbon emission, and we have to be prepared for it. And
so you have been confronted with a crisis and with a concrete problem, and you needed to adapt. So I think this is a great segue to go a little bit deeper now and help us to understand which kind of different measures and tools do you see that manufacturing companies become more robust and they can counteract against that crisis. I know that you are thinking about some kind of framework here. You call that the CRISP framework.
Yeah, this is our narrative, and thank you for mentioning this. The CRISP narrative, which we brought out, it is our guiding principle. As first of all, it is very good to communicate, and it's very important that to buy into that. What you said, no, you would like to that all your teams are pulling into one direction. So you need, of course, a narrative. What are the guiding principles? And the CRISP narrative for us was a way to describe it very concrete. So the C is of the CRISP. So our factories and our network needs to be connected. And what means connected for us? So this is, of course, the IT convergence into the cloud, what we see, and to use the power of the cloud, of the hyperscalers, for data sharing, but also for training and strengthening algorithm, but also connection to the shop floor, because you need to connect your assets to make that what is happening on the shop floor transparent, and have the detailed information on that what is going on. But connected also means the factories in between, the assets in between, so that they can share information. So this is the C, and the C comes, of course, with the responsibility of cybersecurity. This is the other C in this CRISP. If you're going more to cloud and you connect your assets to the cloud, of course, and you have this IT, OT convergence, so cybersecurity becomes a very important topic. The R stands for us for the resilient and robust.
Before we go to the R, I would have a question.
Yeah, sure.
Regarding the connectivity point. So when we take your CRISP framework, as you said at the beginning, we have that C, and it's about connectivity and cybersecurity. Is cloud still a challenge when we take it into that transformation perspective, or is it now some kind of no-brainer and everybody knows we need to go on the cloud? Where are we?
We need to go to the cloud, as the power in the cloud offers you so many opportunities in regards of training of algorithms, strengthen algorithm. You can bring data and informations together on a completely different level, from different sites, from different assets which are locally separated. So that it's a need to go there and to use this. So you can also have services provided on cloud, which allows to service them in a very efficient way and always have the updated version there without taking care when you would have them on premise. So there are a lot of advantages. But on the other side, of course, if you connect to the cloud, you have to protect your assets. Of course, then cybersecurity becomes something which needs to be built in. There are always solutions, but you have to be very, very careful, and you have to follow design guidelines in this aspect. I give you one example. So we are not connecting maybe our asset with a controller directly to the cloud. We are going over the edge. So we have the edge device sidelined to these asset. So that what we are. So the functionality and the algorithm is developed then on the edge and giving the signals or the information then to this asset. And then from the edge, we are going to the cloud via a connectivity application, which protects our equipment from possible, let's say, risks. So
Yeah.
you need to deal with it and think about how you are frame the architecture.
Yeah, I find it great that there is some kind of mindset change, and in the manufacturing industry, cloud is becoming more and more standard. I give you an example of my company where we started 2017 with bringing checklist work instructions and so on into the cloud. And at that time, 2017, it's not that far away. For some companies, that was not possible. Yeah? They said, okay, there are very sensitive information on a work instruction. We cannot put it in a cloud. And now, 5-6 years later, we are at a different time. And I perceive that explicitly, or especially after Corona and the pandemics, that kind of momentum change was increasing. And now it's some kind of standard that, of course, a work instruction can be in the cloud.
Yeah.
Great to hear that from your side as well.
Yeah, we have data lakes also. We need to have them in the cloud,
Yeah.
as I mentioned it before. Yeah. Mm-hmm.
Okay, let's go to the R, robustness by design. You wanted to start already.
Yeah, resilience and robustness by design. Of course, here the robustness by design means if you need to think about the process itself, the process needs to assure the robustness. The resilience is going into the supply chain. So you have to think about the transparency of the supply chain, and this means what happens in your supply chain beyond tier 1, so tier 2, so that you can assure that your material will still reach your factory and in time. So process by this, the process is very important, and the resilience is for the supply chain. This is the R where we are going and where we are looking into it.
And help me to make that a little bit more concrete. For example, for a company that has 2,000 employees, it's a manufacturer, and the company wants to improve its supply chain. Then, of course, robustness by design sounds important, but how to make it concrete? How can I make sure that I get that robustness?
So if you would have a bill of material, then normally a bill of material has one component. So it is a list of components. But just imagine one of these components is not available, then you cannot build the whole product. But if there is already in the bill of material an alternative component defined, which you immediately could use on a short notice during your production, then this is a robust, because then you can switch over immediately. Another example is that would be then that, of course, you would have an alternative component already on stock. But but this is normally not what you see in production, that you have a bill of material with alternative materials already available. Another example would be, so there is a component not available anymore on the market, and you need to make a redesign. When you make a redesign, then all your software programs during your production, for example, labeling, laser labeling, or your assembly program, or your robot picking program, whatever you name it, normally needs to be adapted to the new to this component because something changed, geography or something. We have our processes completely. We have a complete data throughput that in 20 minutes, the change was on the bill of material. All our processes are updated from the software automatically,
really?
and we can continue to produce. On the resilience, that of course there are resilience means transparency in the supply chain. You need to know what is going on when you will receive material, so that you in the case you see there is a delay, is that you have an alternative program already prepared. Otherwise, your workers are just not able to work. So these were the three examples what we think, what we mean with resilient and robustness. And we talk, of course, about the intelligence of our people. We would like to have them as smart as possible. And we train and we offer, of course, exciting programs which they consume, which they are able to consume whenever they want, as they are available on a learning platform. I think that is very important, as we are introducing new technology on a very high pace. Maybe sometimes, of course, they need to be updated. But the intelligence is here meant also in artificial intelligence. So when we are going back to look into our processes, and especially, I make an example now, as you always ask for example, I like this to make it more concrete. Quality. So quality in electronic manufacturing is a very important topic. In average, 40% of our processes are related to quality assurance. We have a Six Sigma organization, and we have a defect level in our lighthouse factories here in Amberg or in Chengdu is almost on a Six Sigma. We are on a Five Sigma level, so we are striving for Six Sigma. Because if you have Six Sigma, then you can say you have a zero defect factory. So it's very high. So it's about 9 to 11 defects per million. But there is a lot of efforts behind of it. Of course, there's a lot of testing. And we are going into the direction, how can we use artificial intelligence, smart algorithm, machine learning for finding out the good parts, so that we do not have to test them without jeopardizing our quality. And if the quality of a product relies on the process and how the process is then executed, then there must be a process pattern which defines when a product is absolutely good. So now you have to follow. Now think, if you have a 100% quality control and you can identify without any risk exactly the parts which are good, you can skip the test. So, and this is our new strategy, for example, in quality. So we are not jeopardizing, we are testing if there is a doubt. But if there is something exactly in the process pattern where we exactly know this must be good, then we skip the test. And that's the principle of artificial intelligence, how we are using it, process pattern recognition. Other example is, of course, in maintenance. Maintenance is the other big area in full automated production lines. You don't want to have an unexpected stop on your production line. For these, predictive or prescriptive maintenance can help significantly to lower this. And one example would be we have a spindle case for depaneling our printed circuit boards, and we are observing how our spindles are behaving. And we have now a smart algorithm who identifies 6 hours at least before when this spindle will get stuck, so we can plan it and exchange it before it comes to an unplanned stop. And this is exactly what we would like to avoid.
Mm-hmm. So as I understand, you use AI, machine learning currently in a way that you use the pattern recognition and find out if there has been, for example, no problem with a certain part every Monday, then you can assume on the next Mondays there won't be a problem as well. So you do not have to conduct additional testing. So you save resources because you understand the patterns. And the same is with maintenance, where you use patterns you find to improve your maintenance work because it's predictive maintenance. Is that right?
No, I would not say on Monday, because that would relate maybe also to workers. So we are measuring, for example, in a production line, really process parameters. So each step where a value add happens to the product, there are process parameters related to. It could be pressure, it could be speed, but it could be also the height of a soldier paste, or there are a lot of process parameters. So we are measuring in each step process parameters, and of course, due to labeled learning, and we know from the past when parts were good. So this is the training base. So we can train algorithm on that because we have a strong quality base. And then from this, the adventure begins. You have labeled parts which you can label good and bad, of course, and then you start a training algorithm based on this, maybe reinforced tree, decision tree, or whatever, and this gives then the hint when there is a product which were produced inside all these processes, then you know it is good. Only then. So
Okay.
there is a continuous measuring and an immediate evaluation needed to decide if this part will be tested or not. It is real-time measuring and evaluation intact.
Interesting. Okay, understood. Thanks for that explanation.
Guessing that as is sustainability. And I mean, also, and you mentioned it before, I mean, sustainability becomes so important, not in our daily life, but also for production. We need to have sustainable production. We need to take a responsibility along the supply chain and for producing our products. So sustainability means really we have targets. We have, of course, we have for scope 1, which means scope 2, which means, okay, the on-site emissions and the energy we are purchasing to bring this down to zero. And of course, also for the emissions along the supply chain upstream, and we are also measuring and collecting upstream carbon emissions along the supply chain and continuously reduce them. That is sustainability. And for sustainability, you need connectivity, coming back to our C, because you need to measure, you need to collect the data, so you need connectivity. And of course, supply chain resilience is also related to it. You need intelligence for analyzing them. and making the right decisions and putting the right actions in place. Examples are we have holistic energy management dashboard where we are controlling our assets on the shop floor and continuously looking if there are where are the highest energy consumers, and can we improve them by more energy efficient drives or more or more efficient automation routines. We are collecting our data along the supply chain with our suppliers, with our solution, which we are developing, which is called Seagreen, which we are for tracking and tracing, and then putting actions along the supply chain in place regarding our suppliers. So that's all about sustainability. But sustainability is also about our people in our offices, in our on our sites. So we try to be also a good neighbor. So as we are operating in different locations, so we are contributing to photovoltaic, for example, or for information to what you need or what you can do on private life to be more sustainable, or we offering that people come with a bike or the shift systems balanced with the public transportation systems so that there is no need or a lower need to come with private cars. That's also the program.
Okay. So you talk about your workforce, the people, which is a great segue to the last letter of CRISP. It's people centricity, people centrality. How do you call it?
We call it people centricity. People centricity is also multidimensional for us. So people centricity is that we are looking on our operations, on that what we do from the perspective of the people, of our people, and think also what can we do to make their work more enjoyable, of course, but providing also the right information in the right time to them. And the other aspect is, of course, keeping them healthy in a physical, but also in a mental way. The first thing has something to do with technology, of course. So when we are providing information and make it the work more enjoyable, is also bringing technology into it. Digitalization helps. How can we? So one example would be sending information from the machine directly to a smartwatch if there is something they need to take care of. So this means they are not get stuck in front of a machine and waiting that a light gets on, or maybe they get stressed because they have to pass by a machine and look always if this machine is still healthy and working. So they get a push mail directly to their smartwatch or to their handhold or whatever. And then they have this information, which means they can, in a certain way, be more relaxed because they are connected in this environment, in the factory, and they are part of it. Or they can also ask maybe a colleague directly with these handhelds that they maybe support them on an issue because they need help. And the other way is, of course, taking care about safety and in regards of physical health and mental health, and providing support and also tools in regards of this is what we call people centricity. The best way is always.
We talked about AI already at the intelligence point, but I would be curious if you see use cases already where AI and especially the large language models like ChatGPT, where I just can ask anything, As a worker, for example, I need help, I need support, I ask something and I get an answer. Do you see use cases in that direction in your company?
Definitely, definitely. We are experimenting, of course, with these opportunities and with the possibilities from this. I mean that just as we know that there are more experienced people and people who are maybe just onboarded would like to participate from this experience. So we are working on an experience database where the people can ask if this problem occurred already and how it was solved on this in this machine. Um, but also what you just said, that we are experimenting, of course, with the large language models, but of course at the moment we are not using open ChatGPT, as this is not safe, and we're coming now back to cybersecurity and also confidentiality, you know. So yes, we are experimenting this, but in a closed environment, of course, in our infrastructure. And we see a great opportunity, especially on solving problems on the shop floor in a shorter matter of time.
Okay, Gunter, great. I learned a lot already. So we talked about the CRISP framework or the CRISP approach, which is the way how manufacturing companies can adapt and can transform to counteract certain crises. And I would like to come to an end step by step. And I would like to ask you, having that framework in mind, that CRISP framework, I assume that you already conducted different kind of transformation projects with that framework. Is there a specific project where you say, I learned a lot at that project? And yeah, what was it? What did you learn?
I mean, now as a personal learning curve, I would like to point out really the power of creativity. If you are giving into a team a vision, I mean that's a little bit not that what you ask for a transformation, but I think I would like to point out again that in our times when we are in very complex environments, sometimes we do not have time to think and to be creative, as we get stuck in this overwhelming complex situation. But when you take a step back and bringing people from different mindsets together and asking them for a solution on a specific problem, and you have a vision, it's incredible what there can be done if you provide a safe space where they can try out, where they can um, be experimental, where you allow them to make failures and to learn fast from them, and bringing up a solution out from this creative environment in a very unexpected and very impressing way. That's something I just wanted. That was my learning, which we should use more often in our environment as they become more and more complex. And I think our people and we are getting stuck in this complexity and trying to manage this. We need to bring our teams which are working on solutions, giving the space in co-working areas. That is something we need to build in this, and this drives really transformation programs.
And we need to dedicate time for it,
Exactly.
and we need to dedicate time for our teams. Yeah. Okay. Got it. You talked already about having a vision. So coming to my closing question, I would like to understand how you envision the future of manufacturing companies. Probably all of the manufacturing companies will conduct your CRISP framework and they will transform. How does the world look like 10 years from now? How will the manufacturing companies operate?
Yeah, I think really that CRISP is really a guiding principle. From 10 years from now, I think every factory, all the operations need to operate in a very sustainable way. But that is one really thing which will drives which will reshape production and manufacturing setup. If you think this through, this will lead to even more bringing production sites closer together. So we will see more and more, let's say, setups where suppliers and suppliers along the supply chain needs to come together in smaller factory setups that we are not allowed to ship, and we are not able to ship our products around the globe for small value add steps. We have to think in more these setups where complete products can be produced in a very high efficient way, but close to the customers, close by, because then otherwise sustainability will not be reached. The other thing is circularity. If you think these topics through, this means we need to bring into our factories used, recycled material on a higher volume as now, no? Because circularity means the lifetime of products will be expanded, or we need to refurbish them. So our factories are not set up for this. We need to think about how we are going to now design factories which are made for circularity, because this brings us back to robustness. What does it mean when we bring more recycled material, more used material back into our production setup? And still we need to assure quality. I do not have an answer to this. I just phrase these are the challenges we need to solve. And so that are the game changers for me in the future. It's still sustainability. It's still it will be circularity due to material shortages, due to energy shortages, and due to geopolitical new setups. That is what we have to think about.
Yeah. Okay. Gunter, sounds like a big vision, but we still have challenges in front of us. It was a pleasure to talk with you. Thanks for being on the show.
Thank you for the questions. It was a pleasure to be here, Benjamin.